Welcome, second graders, to a super special explainer. Today, we're throwing open the doors to the Math Detective Academy, and I am personally inviting you, yes, you, to become official math detectives. We're going to be exploring numbers all the way up to 1,000. We've got some incredibly colorful number mysteries to solve today, and honestly, I literally can't do it without your sharp eyes and quick brains. But first, I need to know you're fully committed to this mission. So, point right at the screen, take a massive deep breath, and shout your answer out loud. Are you ready to be a math detective today? Wait, I actually heard that. That was a huge yes. Excellent. Go ahead and grab your invisible magnifying glasses because it's time to gear up for our very first official mission. Mission 1, the hidden number square. Okay, so we've got a bit of a situation here at the Academy. Someone accidentally spilled brightly colored paint all over our top secret math clues, and we need to figure out exactly which numbers got covered up. Look closely at the digits in this 100 square. See those colorful paint splats? Pink, green, red, blue, orange, yellow. But before we uncover them, look all the way over at the right-hand column. You see 10, 20, 40, 70. What value does the digit 0 actually have in that right-hand column? Think about it for a second. In the number 20, the 0 is in the ones place. That means there are exactly 0 extra ones. It's perfectly grouped into tens. That's a massive clue for how this whole grid works. Let's put those brand new detective skills to the test right now. Look right at that bright blue splat right in the middle of our grid. We can actually use the numbers right before it to solve the mystery. Read them out loud with me. 62, 63. So, what number is hiding under the blue? Shout it out! You got it! 64! You literally just cracked your first code. By counting on, we can uncover every single missing number on this board. All right, moving right along to Mission 2, breaking down big numbers. Brilliant work, detectives. Now we get to tackle a brand new challenge. Learning a secret tool for handling giant 3-digit numbers so they aren't scary or confusing at all. To do this, we need to learn a very important detective word, and that word is decompose. Now, when we decompose a number in math, we're really just breaking a big number down into smaller, easier pieces. Think of it kind of like taking apart a giant toy block castle. When it's all built up, it looks huge, but when you decompose it, you just separate it out into its individual pieces, the hundreds, the tens, and the ones. Let's practice this together with a real 3-digit number. How do we decompose 234? Well, it's just 3 super easy steps. Step 1, find the hundreds. We look at the first number, the 2. That gives us 200. Step 2, find the tens. The middle number is a 3, which means 3 tens, or 30. And finally, step 3, find the ones. That last digit is a 4, so we just have 4 ones. So it's 200 plus 30 plus 4. And this picture perfectly shows us exactly what we just did. Look at these place value blocks for the number 234. You can literally see the decomposition. We've got 2 large 100 squares, which proves the 2 has a value of 200s. We have 3 10 rods, so the 3 has a value of 30. And finally, those 4 tiny single blocks showing us the 4 ones. Now, use your detective eyes for a totally new number, 312. How would we build that one? Well, we'd need 300 squares, 1 10 rod, and 2 ones. When you can visualize the blocks in your mind like that, no 3-digit number is ever going to trick you. Mission 3, even and odd patterns. Okay, so you are officially experts at breaking numbers apart. Let's use that skill to spot some secret patterns. Mathematics is really all about finding the hidden rhythm in numbers, right? So an absolutely crucial point here is knowing the difference between even and odd. Even numbers always end in 0, 2, 4, 6, or 8. Come on, chant that with me. 0, 2, 4, 6, 8. Odd numbers always end in 1, 3, 5, 7, or 9. And the biggest detective secret here? When you're looking at a massive number, you don't even need to look at the hundreds or the tens. Nope, you only ever look at the ones digit at the very end to crack the case. Let's see how this works in action. Here we have 2 students trying to solve a tricky puzzle. The boy on the left says, I think 500 is odd because 5 is an odd number. But do you agree with him? Look really closely at the number 500. He made a classic rookie mistake. He looked at the hundreds digit, but we know our secret rule, right? We only look at the ones column. The ones digit in 500 is a 0, and 0 is even. Therefore, 500 is an even number for sure. The girl on the right is looking at 889. Now, it has 2 8s, which are even, sure, but that last digit, the ones digit, is a 9. so 889 is entirely odd. Mission 4, let's estimate the fish. Incredible job so far, detectives. Now grab your scuba gear because we are taking a deep dive underwater. We're going to learn a highly important mathematical tool called estimating. Now, what exactly is an estimate? Well, an estimate is a smart, careful, and reasonable guess based on what we can clearly see. It is absolutely not just closing your eyes and shouting out a wild random number. It's about using the clues right in front of you to make a choice that actually makes logical sense. Let's look at this beautiful underwater scene. Up at the top, we have a bright, colorful glass fish tank. Look at the size of it and the fish swimming around inside. Now, guide your eyes down to the giant, crowded sea at the bottom. Notice how many tiny fish are swimming around in those huge schools. If we had to guess the numbers for each, our guesses would be completely different, wouldn't they? So ask yourself, why is our estimate for the giant sea going to be so much bigger than the small glass tank? Just think about the space. A small tank can only hold maybe 10 or 20 fish, just a few tens, really. But the ocean is massive. An ocean holds hundreds or even thousands of fish. So by just looking at the space and the groups, we can make a totally reasonable estimate without having to sit there and count every single tiny fish. Mission 5, counting tracks and jumps. All right, this is it, our final obstacle course before graduation. We have to navigate the counting tracks, which basically means we need to make some giant math jumps forwards and backwards. So stretch those legs. We're going to start by jumping by 100s. I want you to literally jump in place wherever you are every single time a new number pops up on this timeline. Ready? Jump. 0. Jump. 100. Jump. 200. Jump. 300. Jump. 400. When you jump by hundreds, the tens and ones stay exactly the same. Literally only the hundreds digit changes. And this brilliantly builds in to counting from literally any starting number. Check out the boy on the screen. He is laying down a real challenge for you. He says start on 25, count up in hundreds. What would that be? Well, 25, 125, 225, 325. See how the 25 stays exactly the same? Now try his next one. Start on 199, count down in tens. Okay, so 199, 189, 179, 169. You're just changing the tens digit by jumping backwards. The final puzzle. The time has finally come. You've uncovered hidden numbers, decomposed digits, spotted even and odd patterns, estimated the ocean, and jumped through counting tracks. It is time to prove you are master math detectives. Let's move to this final page of challenges. Look at all those number lines with missing numbers. We've got plus 10 jumps, minus 10 jumps, minus 100 jumps. But I want you to focus all your attention on the trickiest problem of the whole bunch, right down there at the very bottom left corner. The boy in the yellow shirt is giving us a real riddle. Listen closely. I think of a number, count on 100, count on 10 more. I am on 250. What was my starting number? Okay, so to solve this, you have to use your best detective skills and work completely backward. We start at 250. Instead of counting on 10, count back 10. That's 240. Then, instead of counting on 100, count back 100. 240 minus 100 is 140. The starting number was 140. I'm officially assigning you the rest of these puzzles as your homework mission. You've learned exactly how to decode the secrets of math today in this explainer. The real question is, what number mysteries will you solve next?